Hi and welcome to Radicals and Systems Day 1. All right, today we're going to start by focusing on square roots and cube roots. So for exercises 1 through 4, describe each step taken to solve the equation, then check the solution to see if it is valid. If it is not a valid solution, explain why. So in this first example, what we did is we added 6 to both sides. And then to get rid of the square root, we squared both sides. To undo a square root, you have to square it. And so we got x equals 100. And what I need to do for a check is just sub in. So the square root of 100 minus 6 equals 4. And the square root of 100 is 10. Minus 6 equals 4. So 10 minus 6 is 4 equals 4. So that works. So it's a valid solution. For number 2, we added 6 to both sides, just like we did in the first problem. And then to get rid of a cube root, we have to cube both sides. And 10 cubed is 1,000. So we need to check. The cube root of 1,000 minus 6 equals 4. Well, the cube root of 1,000 is 10 minus 6 equals 4. So 10 minus 6, 4 equals 4. We're good. So this one is valid. All right, for the next one. Minus 6 minus 6. So the square root of x equals negative 2. Square both sides. So x equals 4. We need to check. So square root of 4 plus 6 equals 4. Square root plus 2 plus 6 equals 4. 8 is definitely not equal 4. Therefore, this is not valid. So there is. Hang on. So it's not. There's no solution. So that's not a solution. Rejecting days somehow. All right, for number 4, subtract 6. Cube root of x is equal to negative 2. This time we're going to cube both sides. So x equals negative 2 cubed is negative 8. So then for my check, cube root of negative 8 plus 6 equals 4. Well, the cube root of negative 8 is negative 2. If you don't believe me, check it on your calculator. And you can use your parentheses around the negative 8. Negative 2 plus 6 is 4 equals 4. So that checks out. So that makes this valid. So for example 1, solve a radical equation. Be sure to check the solutions. Well, first thing we need to do is isolate the radical. And then get rid of the radical. And if it's a square root, you square it. If it's a cube root, you cube it. And then the last step is to check. Your favorite thing to do. Remember, math is fun. So the first thing I need to do to get the radical one is add 2 to both sides. So I have the square root of 3x plus 5 equals negative 1 plus 2 is 1. I'm going to square both sides. So when I square both sides, the radical just goes away, and I have 3x plus 5 equals 1 squared is 1. Subtract 5. 3x equals negative 4. 3. So x equals negative 4 thirds. Now we just need to check our answers. Or answer, I should say, we only got one. So I will have 3 times negative 4 thirds plus 5 under the radical minus 2 equals negative 1. Here this 3 cancels with that 3. So then I'll have negative 4 plus 1, plus 5 under the radical minus 2 equals negative 1. Negative 4 plus 5 is the square root of 1. Minus 2 equals negative 1. And the square root of 1 is 1. Minus 2 equals negative 1. So negative 1 equals negative 1. So that works. Next page. 15 or 5 through 15. Solve each radical equation. Be sure to check your solution. All right, the first thing we have to check and make sure is if our radical is isolated. And in this case, it is. So the next step is to square both sides. So I will get 2x minus 3 equals, the square root is 121. Add 3. So 2x equals 124. Divide by 2. X equals 62. So check. 2 times 62 minus 3 equals 11. So the square root of potentials is 124 minus 3 equals 11. So yeah, 121 square root of equals 11. The square root of equals 11 equals 11. So we are good. For number 6, the radical's alone, but that's a cube root. So I have to cube both sides. So I will get 6 minus x equals negative 3 cubed is negative 27 minus 6. So negative x equals negative 33 divided by negative 1. So x equals 33. Check. Cube root of 6 minus 33 equals negative 3. Well, the cube root of 6 minus 33 is negative 27 equals negative 3. Cube root of negative 27 is negative 3. Don't believe me? Go check your calculator. For number 7, this time my radical is not isolated. So I have to add both sides. So the square root of x plus 5 is equal to negative 3. I need to square both sides. So x plus 5 equals 9. Subtract 5 from both sides. So x equals 4. So let's check. I have the square root of 4 plus 5 minus 9 equals negative 12. The square root of 9 minus 9 equals negative 12. That would be 3 minus 9 equals negative 12. And negative 6 equals negative 12. So negative 12. And that is not equal to. So we have to reject that. And no solution. Number 8 looks really crazy and even intimidating, but there's two radicals and one's on each side of the equal sign. And since there's no other variables, that's fine. We're just going to go ahead and square both sides. So we'll have 4x minus 7 equals 3x plus 9. Subtract 3x from both sides. So x minus 7 equals 9. Add 7. X equals 16. So for my check, I will have 4 times 16 minus 7 on one side, under the radical. On the other side, I'll have 3 times 16 plus 9. Well, 4 times 16 is 64 minus 7. Equals 3 times 16 is 48 plus 9. So I will get the square root of 57 equals the square root of 57. So that works. So we're good with 16. For number 9, I have two choices on how I want to work with this one. I can work with this one and square it like it is, and square each term, or I could divide by the number out in front of the radical and then square it. Doesn't really matter what you do. But in this one, I'm going to do this. So radical x minus 6 equals, if I reduce that fraction, 3 goes into both of them, so it'd be actually bigger. 6 goes into both of them. 3 halves, negative 3 halves. Square both sides. I will have x minus 6 equals 9 halves. So I'm going to add 6 to both sides. I'm going to add 6. I'm really adding 12 halves. I just made a common denominator in my head. And that would be 21 halves. Alright, for our check here, it'll be negative 12 times 21 halves minus 6 equals 18. And I can tell that no matter what I do, this isn't going to work, because there's no way I'm going to get a negative when I simplify my radical. And without another negative, this will not work out. So we're going to reject this answer and say there's no solution. For number 10, we have the same situation, except this time it'll work out a little nicer for us. We will get 4 when we divide, and then we need to cube both sides. So we will have x plus 2 equals 64 minus 2, and we'll get 62. So let's check. 3 times the cube root of 62 plus 2 equals 12. So it's 3 times the cube root of 64 equals 12. Well, the cube root of 64 is 4, and 3 times 4 is 12. So that works. So we're good. All right, here we go. 11. Well, let's square both sides. And when I do that, I'll have x squared minus 5 equals 4. So add 5 to both sides. X squared is equal to 9. We could also move that 9 over and then factor. I probably should have done that first. Oh my goodness, no squares. So we have x equals negative 3 and x equals positive 3. So unfortunately, when you get two answers, that means you have to do two checks. So the square root of negative 3 squared minus 5 equals 2. And it is a negative. And when I square that, I'll get 9 minus 5 equals 2. Square root of 4 is equal to 2, so 2 equals 2. So negative 3 works out. And that should mean the other one works out. 9 minus 5. And we'll get square root of 4. So 2 equals 2. So they both work. Number 12 is very similar. Square both sides. Oh, sorry. Just doesn't like to write on that one spot on my screen. Equals 9. So subtract the 9 from both sides. And then we'll have to factor. Factors of 9 that subtract to give us our 8 are 9 and 1. Plus 9 minus 1. So x equals negative 9. And x equals 1. Well, it's that time to do your favorite thing. Check. So the square root of negative 9 squared plus 8 times negative 9 equals 3. So the square root of 81 minus 72 equals 3. So when I subtract, I get 9. Square root of 9 is 3, so 3 equals 3. So negative 9 works. And then I will have 1 squared plus 8 times 1 equals 3. So I'll get 1 plus 8 equals 3. This is promising. The square root of 9 equals 3. So 3 equals 3. So they both check. So they both work. Oh, yay, fun. Multiply each expression. Well, the square root of x times the square root of x will be x. Square root of x times negative radical 2 is negative radical 2x. 2 times radical x is plus 2x. 2 times negative 2 is negative 4. Plus a radical 2x and a minus, oops, it's radical. A minus 2 radical x and a plus 2 radical x cancel each other out, so you're just left with x minus 4. And I'm going to let you try this one. And this number 15 is a little bit on the tricky side because if you look at it, there is not a binomial times a binomial necessarily. It's a binomial under a radical times a binomial under a radical, which means the radicals are going to, just like saying square root of x minus 5 squared. So the squared and square root cancel each other out. So you just get x minus 5. Okay, we're working there. Almost done. Rationalize the denominator in each expression. That is, rewrite the expression so that the fraction has a rational expression in the denominator. All right. So if there's a radical, just a single radical, you multiply by square root of radical x minus the square root of over x minus 9, square root of x minus 9. in the numerator, you will get, because that you have to distribute. I don't actually have to distribute it. I'll write it as parentheses x minus 9 times the square root of x minus 9 all over. When I multiply those two radicals together, I get x minus 9. And this x minus 9 with this x minus 9 cancel each other. So we're left with just the square root of x minus 9. B is a little bit different. For B, I actually have two separate terms in the denominator, so I need to multiply by the conjugate. Oh, yuck. Let's see here. What do we get? We get an x minus 9 and a radical x minus 3 over a radical x times a radical x is x. I know my middle terms are going to cancel out, so positive 3 times a negative 3 is minus 9. So my x minus 9's go, and I'm left with radical x minus 3. All right, let's see here. I got 3 more to go. Oh my. Rewrite 1 over radical x minus 5 in an equivalent form with a rational expression in the denominator. Well, this is just like B up above. So I have 1 over radical x minus 5. Oh, that's an x, not a 5. So I need to multiply this by radical x plus 5, because that's its conjugate. So I have radical x plus 5 over x minus 25. All done. Solve the radical equation. Be sure to check for extraneous roots. Well, we'll treat this like a rational equation like we did in the last unit. And I'll multiply everything by the LCD, which is the square root of x plus 3. So here they cancel out, and I have 3 equals the square root of x plus 3. Now I need to square both sides, so I have 9 equals x plus 3. Subtract 3 from both sides, so x equals 6. And then we need to check. So I have 3 over the square root of 6 plus 3 equals 1. So I will have 3 over the square root of 9 equals 1, which will then be 3 over 3, which equals 1, so 1 equals 1. Yay, it works! So my answer is 6. My last problem. Without solving the radical equation, square root of x plus 5 plus 9 equals 0, how could you tell that it has no real solution? Well, I'm not going to actually solve it, but I am going to isolate it. Now, when you look at that, there's no way that you can take the square root of a number and get a negative answer without there being another negative outside the radical somewhere. So for me, that's all I needed to do. If you didn't do that, you could look at the original problem and see that this needed to be equal to a negative number. If I have this, here, there's no way that that's going to be negative. Again, same idea. And since that's never going to be negative, I can't add 9 to it and then get 0. All right, sorry that this was a little bit longer than I expected. Hopefully the next one won't be so long.